Hey, what is up guys, NVASS here, and this is another video in the Code with NVAS series. This is problem number 3 that I'm trying to solve on video. The source of this video is same as the source that we've discussed in episode number 2. It is from a YouTube video from a person called Nick White, and the title of the video is Pramp Mock Technical Interview Data Structures and Algorithms. In my previous video, we've seen a problem which is discussed in the first half of this video. Like I said yesterday, I haven't seen the solution, but looking at the question, I felt like I want to solve that problem. After filming and editing that video, I continued and watched that video. It was good. Later, I came across this question in the same video. It is BST successor search, or it is like InorderSuccessor of a node in a binary search tree. Again, I find this question really interesting, so I looked up for that question in LintCode. I said InorderSuccessor in BST LintCode, and it turns out it is a premium only problem, so I have to have a premium subscription in order to get that question and try to do that. So I did what every other sane person would do. I googled the question and saw if there is any other website which is providing that, and I came across this website called lintcode.com. Okay, I have never seen this website before, but it looked good, and it has the question in order successor and BST. So apparently it is also like LintCode, maybe, because it's having a problem number and a problem description and related questions. So there are a lot of features that are similar to what I see in LintCode, and here I see the difficulty level. So the difficulty level of this question is medium. I don't remember what was the difficulty level in medium in LintCode. Okay, that is also not mentioned. So I think I don't know. I'm not sure if the difficulty level is easy or medium. But here it says it is medium, and it has some stats about the question, and it has an IDE where I can open and try to solve that problem. Alright, so that is the backstory. Now let us get into the question. So the question is InorderSuccessor in BST, that is the title. Given a binary search tree and a node in it, find the InorderSuccessor of that node in the BST. Let's write our plan of action here. Initially, I'm thinking there are two styles of dividing it. One is has a right child, and it's an IDE, so I'm getting prompts. Alright, doesn't have a right child. Because I think if you have a right child, then it sort of becomes simple, because in a given binary search tree, I think I need to find a good binary search tree example. Good. So now if I have 3, all right, so the immediate next node would be the right child's leftmost node, right? Because 3 is a number, and numbers that are greater than 3 will definitely be on the right side of 3. So I can exclude everything that is on the left. And if I have a right child, I'll go to the right child. Now 6 is the number, but immediate successor is something that is greater than 3 and smaller than 6, potentially. Like if there is no other number which is smaller than 6, then definitely 6 would be the immediate successor. So it would be greater than 3 and less than 6. So I'll go as much left as possible to find out the successor of that node. So a successor for a node which is having a right child would be one step right and everything to the left. That is one style of doing it. And the other case that I'm thinking of is if it does not have a right child. Like for example, I have 1, right? So if 1 is not, 1 here is not having a right child, so I can't take that approach. So what I would do now is I'll have to somehow go to the parent. Do I have access to the parent? Left, right. Okay, there is no access to the parent. Okay, you need to find the successor node of P. Okay, I'll be having a root node. But there is no. Okay, that is a good question. So when I was looking at this question had a parent object. So I looked at that question and I was really excited to do this. So if it does not have a parent, then I think it gets a little complicated at the moment. Let me go ahead, still break this down and try to do it. So I'll start from the root node. I'll first have to find out that specific node, right? So I can do a BST traversal to go to that node and find it out. I can, see which node it is. but I should somehow keep track of all the parents that all the nodes that I'm visiting, because somehow I need access to the parents. Okay, so if it does not have a right child, like in this case for one does not have a right child, I'll have to go to its parent, all right? And the immediate successor of 1 should be its parent. Is that true in all cases? Not necessarily, right? Because 7 is a leaf. Okay, if it is a left subchild, then the immediate because for 6, now the immediate successor should be its parent. If it's a left leaf, then the immediate successor should be its parent, because there is no other value which is between 4 and 6 if 4 is not having a right child, because if 4 is having a right child, then the equations will change. But if this is a left leaf, then the immediate successor or the in-order successor for 4 would be 6. So the parent will be the final answer, right? Because if I go one step above, depending on left or right, it will be either greater than or less than that node. If it's greater than, then it means there is a number between 4, there is 6 which comes between 4 and that number, which is not what we want. We want the immediate in-order successor. Successor is the immediate next element. So I think if it's a left subchild, then first parent would be the value. If it is a right subchild, here it gets kind of tricky. So if it's a right subchild, I'll have to go up. If I'm going up, it means it's a node which is smaller than that value. And I'll probably further go up here and further go up here. So I'll have to go up until I find an element which is I'll have to go up until I find a parent which is having a value greater than this value, right? Now here I have 7. Let us say this one is 9. And is there any other way where I can place 8? No, right? If this tree, if this value is 9, and if this tree is supposed to have a value 8, then it has to be a right child of 7. Apparently there is no other way I can place that. So I'll have to just go up the parent ladder to find out the node which is greater than 7. And there definitely should be, because if it's a number x, and if it's on the left side of, if that node that we're having is on the left subtree of that number x, then we know every node on the left subtree is less than the root node, right? Assuming there are no duplicates. I'm not sure if this one's having duplicates. Did they mention anything? It's guaranteed P is 1 node in given tree. Okay, there is nothing mentioned about the duplicates. Let's not dig into the duplicates at the moment. So my root node, the parent node, as long as I keep traveling up and up and up, and the moment I find the node, a node which is having a value greater than 7, then I can declare that is the in-order successor. Will I ever have to go to the right subtree if it's this case, like I'm having a right leaf and I'm trying to go up and up? Okay, what if I have something like 17 here? Then if I have 17, then 17 is not having an order successor. I'm going to its parent, 14, 10, 8, null, so it doesn't work out. Now 13 is not having a right child, so 13 is a left subchild, so I'm going to its parent and it's good. So if it is a leaf node, then its immediate parent is the in-order successor. Can we say that? If it's a leaf node, then there is apparently no number between itself and its parent, right? Because if there is a number between itself and its parent, it has to be in the right subtree of that node. So if it's a leaf node, then its immediate parent would become its in-order successor. If it's a left leaf node, yeah, that is something I should keep in mind. Because for right subtree, right leaf node, then I'll have to go up to 6. Now let us say I have a number 2 here, right? For 1, I'm having 2. Is there any way I can draw on this? Okay, it's static. So I have a number 2, like I have a 2 here and I have a node 2 here. So for that case, I'll go up. 1 is not greater than 2. So I'll further go up, because if that node, there is no way I'll have the successor in the left subtree of that node. I'll further go up and I find a node which is having a value greater than 2. And that is 3. Now let us say if this value is something like greater than 3, then there is no way I'll find the answer to, you know, there is no way there is other element which is less than 3 and greater than 2, right? So yeah, that's it. So I think I've gone too much into the explanation, but yeah, that's the idea. So if it has a right child, okay, then I would go to right child, and as long as there is, oh wait, I have to go to Python. Python is my language. Okay, let's copy our comments here. Do we have, oh lovely, I have Python. Alright, so if it has a right child, I'll go to the right child, and as long as there is a left element, I'll go, okay, and then I'll traverse left, and then I'll traverse left until I find a leaf. And if it doesn't have a right child, so it doesn't matter if the node is having a left child, because if it's having a left child, then those nodes that are present in the left child are less than the current node. So it doesn't matter if it's having a left child. So all we have to care about is if it's having a right child or not. So if it doesn't have a right child, meaning it's a leaf node in this aspect, if it doesn't have a right child, navigate up to the parent, until you find a node whose val is greater than current value. Can I do that? Yeah, I mean, I think we have given a rigorous explanation on why we can do that. If that is something that is, I mean, as far as I know, that logic should hold. If I have a node in the left subtree, is there a possibility that I have a successor in the right subtree? No, because if that is the case, then I'll have to go through the root element in the middle. So yeah, this holds good. So yeah, I think we have our action plan ready. Let's jump into the code section and start writing. Okay, if it has a right child, right? If root dot right is not null, then find, okay, let's write another method. Find leftmost node of root dot right. Okay. So once you find that, we will return that. Now we should actually write the implementation for the find leftmost node. It should be simple, like find leftmost node. We have, this is not a class level method, root. And do I need the element? I don't think so, right? So for this node, if, so given a node, I'll have to find its leftmost node, like left child's until I find a leaf, right? So if there is a left child which is not having a left child but a right child, is it considered? No, I still will return the left child. So right, while root dot left not is not none, return. Oh, I can just say root equals root left, right? Root equals root dot left, right? And the moment I find the root dot left is none, I would return root. Should I return the value or the node? I'm not sure. Let's go ahead and see. Return root. So find leftmost node is done. Now, given a root, okay, wait. That is not something that we want, right? If p dot right, I'm not supposed to travel from root. So if p dot right, so I'll start. P is the node that is given to me, and I'm supposed to find out the successor of p. And so I'll have to see if p is having a right node. If it's not, if it's having a right node, then I'll go for p dot right and do the find leftmost node. Now, if it does not have a right node, then I'll have to do a binary search traversal. I mean, traversing a BST to find p. I mean, to find the node which is matching to p, so that I get the path where p is existing. And I'll keep all the parent nodes in the stack. So I will probably need a stack. So if p doesn't have right child, I'll need a stack, right? So I'll go with an else because p is not having a right child. What would I do? I need a stack. I'll just use a list. Now, what can I do now? So I'll start with the node, right? Node equals root. I just don't want to mess with the root node. I don't know. It sounds strange, but yeah, I don't want to mess with the root node. So I just take a copy of root node into a variable called node. Okay. Now, while node not equals p, until I reach the node that that is given. While node not equals p, I would say if node dot val is less than or equal to p dot val. So I'm assuming there are no duplicates, so I'll just go with less than. If node dot val is less than p dot val, which means my node is let's go the example, which means like my node is 14, let us say, and p is my node is 8 and p is 14. So then I'm supposed to go to the right? So if node dot val is less than p dot val, I will say node equals node dot right. I'm going to the right step. Else node equals node dot left. What if I don't have that node at all? Yeah, it's given, right? So yeah, this part is covered. Yeah, I remember reading this. It is guaranteed p is one of the nodes in the given tree, so I don't have to worry about whether that node is there or not. Okay, so if it is less than, okay, I'll probably put a condition here saying if node dot val equals p dot val, because that is something that is eventually going to happen, right, when I find that node. So what do I do then? Will this condition be ever true? No. I'm again overthinking. Since we are dealing with node not equals p, you would never have a situation where node dot val equals p dot val, because if node dot val is equal to p dot val, then node is equal to p, right? According to this logic, compare the memory addresses. Node will be equal to p. If node is equal to p, then this condition will not hold. So by the time I'm coming out of this while loop, my node is not no longer. My node is definitely p by the time I come out of that while loop. So what is the key thing that I'm planning to do? I'm planning to push everything to the stack, right? Stack dot append Python node. Yeah. So I start with the root node. So my root node is inserted into the stack, and then I'll either go with node dot right or node dot left. And by the time I come to the next iteration, that is stored in the stack. So ultimately, by the time I come out of this loop, my node is same as the p, and this stack is having it's having all the elements that are traversed by this particular tree. So all the parent nodes, all the parent traversals we need. Now what do we do? Now while or what do we do? We need a last in first out approach. Can I just iterate through all the nodes in the reverse order? Yeah, right. For node is confusing. For parent in stack. So how do we reverse a stack? Do we have to reverse a stack? I think it's better we reverse a stack. Reverse the stack. Right? This is how we reverse it, right? We do 0 elements at a time in the reverse order. I'm assuming that's how it reverse. I mean, since so lists don't have a reverse method in Python, and that is how we reverse elements in a stack. That is how we reverse elements in a list in Python. So for each parent in the reverse order, what I would do is, if parent.val is greater than p.val, return parent. Right? Is there any way I reach the root node? And yeah, for root, like root node is the last element, right? So for root node, at least for the root node, it should match. It should be greater, not greater than or equal to, but greater. Return parent. Okay, I think we've covered all the bases here. So it kind of looks a little messy for me right now, but if we have a right child, then it's simple. We'll find the leftmost node of its right child, and if it's not having the right child, meaning it's a leaf, then I'll start from the root node and traverse until I find that node. That is the logic that I have here, and then I'm putting everything in a stack, and then I'm taking every element that is the parent element, every element in the path from root to that particular node, and trying to pop things out. I'm trying to go up and up in the list to find out if there is an element which is greater than parent, and there definitely should be, because according to basic binary search tree, there is no way you cross the root node and go to the right subtree if you have this in the left child. Okay, what if it doesn't have a successor? That is the case that I wanted to discuss. I forgot. So now, what if we have 14? Then I'm going up. There is no successor, right? Because 14 is rightmost element in this BST. So if there is none, what am I supposed to return? Null. And so by that time, I'm traversing the entire list, and I reach the root element, and root element is also not greater. So return none. Yeah, it looks like a good idea. Oh, what is this play button? Oh, I can have countdown. I didn't know that. Okay, I'll find out the time I've taken to do this problem while editing the video. That's not a problem. Let's run a test. What? Okay, I'm supposed to log in and do this before I run the tests. Okay. I'm not sure if I just have to log in, or it's a paid platform or something. I didn't verify that before starting the video. When you accepted a problem created. Okay, where is my video? Where is my problem? Where is my code? I didn't even take a copy of that code. Please keep my code. Please keep my code. Oh, good. Okay, I almost thought I lost the code. Alright, let's go ahead and run the test. I accept it. Okay, this is how I input values. Okay, this is a simple case. Output expected to 1 parameter per line. So I'm supposed to give a tree node with value 1. Okay, this is a little crazy. How to understand a test case. So writing test cases, giving test cases is a little tricky. Let's try it anyway. So for this BST, we have 8, 3, 10, 1, 6, hash 14. Okay, let's go ahead and give that. Where is it? Yeah, I have 8. One moment. So I have 8, 3, 10, 1, 6, hash 14. 1 doesn't have any children, so hash 4, 7, 13, and I'm not worried about the last hash because it's not given in that example. So what am I supposed to find out? Node with value 1. Let's do the InorderSuccessor for 1. It should be 3 in this example. And I'll take the same tree and give different cases because it makes life easier. What if it is 1, 3 is a similar case to 4, 6. What if it's 6, right? So 6, and I have 7. These are different scenarios, right? So 1, 3 is similar to 13, 14. What if it's a root node? right? I mean, it's similar to, you know, having a right child. It's not a very big deal, if I am thinking right. Let's go ahead and give the root node as well. And what's 14? So 14 should return null. Yeah, I think I covered all the test cases that we initially thought of. There could be more that we didn't think of before, but yeah, let's go ahead. I accepted. So did it test all the test cases? It said output to accepted only for one of them. Wait, is it testing only the first 2 lines? Answer for this should be 3, right? Let's run it again. Yeah, accepted. I think it's only testing the first 2 lines. I'll keep a copy of these somewhere. Okay, so I'll get rid of the first, this one. Run test. For 6, the output should be 7. Good. And what is the next test case? For 8, right? So for 8, the output should be 10. 10 is the successor. So for 8, let's go ahead and try. Oh, I like LintCode in this aspect because I can test all of them at once. So for 8, 10, that is good. And the next one is, I think this is the last one. For 14, it should return null because 14 is the rightmost subtree, doesn't have a right child, and its parent doesn't meet it. So it should be null for 14. Yep. Let's go ahead and submit. So we've figured out some test cases. 8% of test cases passed. Oh, we're getting an exception. Wait, can the root node be null? I mean, can P be null? Oh, okay. Input is an empty tree. Okay, P can be null. I didn't know that. Okay. Okay, if it were an actual interview, then I would probably ask the interviewer, but yeah, I have to go through this. So if P is none, if the, okay, I can say P is none. I mean, I can either go for root is none or P is none, because if root is none, then absolutely there is no chance of having a P, because P must be in the tree. It doesn't matter whatever I take. So if P is none, return none, right? And submit. 25, 42, 58, 67. Okay. Oh, okay. Your submission beats 81%. Okay, that doesn't matter. 100% of test cases passed. So all test cases are passed. Okay, I think this is a long video again, but mostly it has been long because I was exploring this IDE. I was kind of screwing up with this example, and this one had me. Like, I didn't know I was supposed to log in. I mean, yeah, it makes sense. I mean, LintCode also expects me to log in, but yeah. And I was actually worried that my code would, I would lose my code when I logged in and opened the question, because when I opened it in Java, I find my code empty and I was like, oh goodness, I missed it. And then I went back to Python, and yeah, that is good. And these are the test cases that we've thought of. We didn't think of the root being empty, the tree being empty. It was not given the constraints as well. But yeah, it makes sense. I think it's good progress. Okay, am I meeting this challenge? What is the time complexity for this question? Okay, that's actually a good thing I can do. Like I can try to come up with a solution and try to figure out what is the time complexity of that solution. But that is something that I didn't think of. This was given in this book. There's a chapter called time complexity, and it is, most of the interviews do ask time complexity. So it makes sense to practice those. So what would be the time complexity? Finding leftmost node would be, if it's a left skewed tree, I will have to travel through all the nodes, which in turn is the height of the tree, right? If it's like left, then this one would traverse through the entire height of the tree. So if p.right is not none, so in this scenario, I'll have O of H, height of the tree. That is the worst case scenario, because if it's a balanced tree, and even if it's a balanced tree, then it doesn't make sense. I mean, it's not any different. Even if it's having right child, I'm not worried about it. I'm going left, left, left. So the worst case I would go is until I find the left subtree. No, until I find the left leaf node, leftmost leaf node, which is less than the height of the tree. And in this case, I'm starting from the root node, and I'm going down and down and down to find the leaf node. So I'm traversing throughout the height of this tree. So that is O of H. That itself is O of H. And then I am having another for loop where I'm traversing back, like parent to parent to parent. So even there, I'm not crossing, the height of the tree. There is no way I'm starting from the leaf and going up until the parent and then starting in the right subtree, because we've seen that is a ruled out case. So we would start from the bottom end and go on until the top. So again, the maximum traversal that we do would be the height of the tree, right? So it is O of N or O of H in this case, plus O of H. O of 2H, we drop off all the constants, so that would be O of H. So yeah, I think this challenge is also met. What do you think? I mean, if you followed me through the entire program, then let me know if I'm making any mistakes. And you can also tell me if I met this challenge appropriately or not. I mean, as much as I understand, based on what I see, I think I did good. But yeah, that's the point of interview, right? Self-prep versus interview. In an interview, you have a person who is actually in front of you with his perspective. So there is something that you believe is right, but if it's wrong, then there is nobody to tell you in this kind of videos unless you figure it out by screwing things up. Anyway, yeah, I think that is the end of this video. Again, thank you guys. Oh, there is something wrong with this video. I'm unable to play this. Anyway, thank you so much, Pramp website and Nick White again. These are two good questions that help me get started. So yeah, that's pretty much it. That's the end of this video. If you like this video, make sure you hit that like button. It helps the video and also the channel. If you want to watch more of these videos or more videos that are going to come up in other series, then make sure you subscribe to this channel. And if you want to get notified every time I make new videos, then make sure you hit the bell icon. Alright, so as always, thank you very much for tuning in. I'll see you next time.